For decades, the mantra in AI has been pretty simple. Go deeper. Just stack more and more layers. But what if that's been like looking at a flat, two-dimensional picture of a three-dimensional world? Well, today, we're diving into a paradigm-shifting idea that suggests the future of AI isn't about getting deeper, it's about becoming multi-level.
To really get our heads around this, we have to start with a kind of baffling question. We've got these incredible AI models, right? They can write code, they can make art, they can answer just about anything you throw at them. So why is it that after all that training is done, they can't actually learn anything new?
And that question brings us to what you could call AI's amnesia problem. It's the core reason why today's most powerful models are, in a weird way, brilliantly static.
To really understand this, here's a powerful analogy. A large language model's knowledge is basically frozen in time the second its training is over. It can't form new long-term memories. This is incredibly similar to a real neurological condition called anterograde amnesia, where a person can't create new memories after some kind of injury, even though all their old memories are perfectly fine. The AI is kind of stuck with only its pre-injury knowledge.
So here's the bottom line. Once an LLM is out in the world, it's really only working with two things. First, that massive but totally fixed library of knowledge from its training. And second, whatever little bits of info you can squeeze into its short-term memory, what we call the context window. And that static nature, well, it's a huge bottleneck. It's what's holding us back from creating AI that can truly adapt and learn continuously.
Okay, so if our current digital approach has this massive limitation, where do we even look for an answer? Well, how about the most sophisticated learning machine we know of? The human brain. You know, the one system that literally never stops learning.
The brain gives us a blueprint, and it's all about this incredible concept called neuroplasticity. See, your brain isn't some rigid, fixed computer chip. It is constantly rewiring itself, making new connections, strengthening old ones. This ability to literally change its own structure is the secret to how we learn, and it's something AI can definitely learn from.
And here's the second piece of the puzzle: timing. Your brain doesn't just have one clock speed. It's running on multiple frequencies all at once. You've got your slow delta waves for deep sleep and your super fast gamma waves for intense focus. This multi-speed processing is what allows it to handle information over different timescales. Some stuff gets processed in a flash, while other memories are built up over time. And that insight is absolutely critical.
So, the big question is, how do we take these amazing ideas from biology and actually apply them to AI? Well, taking inspiration from the brain's structure and its multi-speed processing leads us to a whole new dimension for AI. It's called nested learning.
And this slide right here, this is the aha moment. On the left, that's how we usually see a deep learning model, just a straight line of layers. It's totally flat. But on the right, nested learning shows us what's really going on. The model is actually a stack of different learning systems or levels, and each one has its own context and its own speed. It's like we've been looking at the shadow on the wall this whole time, not the real object. So, to put it simply, nested learning is a new way of thinking. It reframes an AI model not as one giant problem to solve, but as a collection of smaller, nested problems. Each level learns at its own pace, focusing on different timescales of information, just like the different wave frequencies in our brains.
And this is the fundamental shift in thinking. The goal isn't just about piling on more layers to make a model deeper. The new frontier is adding more levels to give the model a richer, multi-speed way of learning. We're literally adding a new dimension to how we design AI.
Now, this all sounds really cool in theory, right? But does it actually work in the real world? Well, let's take a look at how these exact principles were used to build a totally new kind of model, one that's designed from the ground up to keep learning. Meet Hope, a model that actually learns how to learn. So here's a side-by-side. On the right, that's your standard transformer model. It's got its attention and its feed-forward network, and they both run at a single speed. They're either training or they're not. But now look at Hope on the left. It's got this core learning block, and then this whole cascade of networks, and each one is operating at a different frequency, from super high-speed updates for what's happening right now to really slow updates for building long-term knowledge.
So how does this thing actually work? Well, first, it has a self-modifying core. This is a mechanism that literally learns how to learn by changing its own rules as it sees more data. It's wild. Second, it uses that multi-speed memory system we just saw, where each block updates at a different rate, just like the brain's waves. You put those two things together, and what do you get? You get Hope, an architecture that's actually built for continuous learning.
But again, the real question is, does it perform any better? Let's check the numbers.
This table from the paper shows the average score on a bunch of common-sense reasoning tasks. A really strong transformer model gets a score of about 52.25. The HOPE model, built with these new nested ideas, scores 57.23. That is a pretty significant jump, and it proves that this new architecture isn't just a cool idea, it actually delivers better performance.
All right, let's zoom out and think about the big picture here. What does it really mean for the world of AI if the future isn't deep, but nested?
This quote from the paper's abstract just nails it. It says that nested learning gives us a real path forward, a whole new dimension for building AI. And by building models with more of these learning levels, we can create systems that can learn in much more sophisticated, higher-order ways.
So, let's just quickly wrap up the key takeaways here. We started with this amnesia problem that makes today's AI static. We saw how the human brain's multi-speed, plastic nature gives us a blueprint for a solution. That led us to the nested learning idea, which completely reframes models as these multi-level systems. And finally, we saw how models like HOPE are the first real proof that this new way of thinking can build a much more powerful kind of AI.
I'll leave you with this final thought to chew on. For years, we've been building AI that can learn from data. This research is opening the door to AI that can actually learn how to learn, that can tweak and improve its own learning process on the fly. So what new breakthroughs, what new discoveries, what new possibilities open up when our most powerful tools finally get that ability?